everyone. Welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today here we have one of our students, Justin, who has completed the course ROS 2 Navigation in 5 days. And at the end of this course, you can present the project that we offer there, and it's implemented on a real robot. So we're going to be seeing autonomous navigation on a real robot from our student Justin here. So hello, Justin, how are you?
Good. How are you?
I am good. Excited to see your presentation. I see that you're already sharing your screen and showing some cool, interesting things. So please go ahead and we can get started with your presentation.
Sure. Okay. So, um, yep, my name's Justin Kibbe, master's in aerospace engineering at University of Houston in Texas, and my focus there is fluid dynamics and robotics. Um, so what I want to show is just the implementation of the goals of the project and show that they work
Mm-hmm.
how intended. And then I'll get into all the little things along the way that I learned. So I've named these spots in a file, and then I'm calling them right now and navigating to them with the path planner, which is all inherent to the to this navigation course.
Mm-hmm.
So we got 1 point, and I figured we would do a brand new point as well for this presentation, if that's
Yeah. And it's interesting because here you can see the replanning done. I saw it went around a couple of times 'cause it chose a different path.
right.
Awesome.
So this did not always work so smoothly. Uh,
Yeah.
there was this huge problem that I had to that I could overcome, and I couldn't figure out until probably about a week and a half ago. Um, so I had just been coming off of the ROS navigation or ROS basics in 5 days and been using the ODOM.
Uh-huh.
So there was my 3 points right there. Um, and so I figured I would grab positions from the odometer because I am familiar with this. I know it does pose position, blah, blah, blah.
Mm-hmm.
So I wrote out when I was going to save my points just to access the odometer, um, go into that pose and hold the points. And it did work. It worked in the simulation. And then when I got into the real robot, um, I was getting so frustrated. I would save a point and then submit that point for navigation. It would go somewhere completely
Different.
different than I
Yes.
wanted. Long time it took me on there to figure this out. But here, um, on the left here circled is the position uh, shown by the odometer. Hang on 1 second. Let me turn this other volume down. I'm getting feedback. On the right is the position by the AMCL pose, and this seemed more legitimate to me because I know that we had been doing the navigation, studying the AMCL and all of that. So I changed where I was saving my position from, or where I was gathering my data from, and it was this AMCL pose. And then after that, everything went perfectly. Um, Read through a lot of y'all's forum posts about this project and learned you had to make a change in all of the config files from the base frame to or
Link.
base link to base footprint. Yeah. Um, Not sure about this, but I did set all the use simulation time to false.
Mm-hmm.
Um, Not sure if that's needed or not.
So it actually is, but nav2, the creators of nav2 configured it so it doesn't matter. So this doesn't fail as much. But if you were to, for example, I don't know if you know Move It or other packages, or if you make your own, it would make a difference because it's grabbing either the gazebo clock or like the real clock. Uh,
Okay,
so,
so I would need to go back in and change that.
oh, but it doesn't matter. For nav2, it
Right.
doesn't matter.
Um, so I can pull up the full code here in a second, but this is the meat of the saving.
Of the
So I
saving of the
of
spots, right?
yeah,
Uh-huh.
saving saving the spots. Um, so it checks for a file in this path with that name. And if it's there, it's just going to add to it. And if it doesn't, it creates the data and it creates them in a dictionary.
Uh-huh.
Um, and records the points. So here is the entire code, where I'm just getting information from the AMCL pose, which this used to be the ODOM pose, which is causing me problems.
Uh-huh.
But it changed this to AMCL, and then down here, like I said, it checks to see if the file is there. If it's not there, then it writes the file and creates the dictionaries until you see this.
Right. So every time you subscribe to the AMCL post, and it writes out the post, and that way you can take it in nav2 later.
Right.
Yeah. Okay.
And the next big challenge. So, as I said, I just come off of the basics in 5 days, so I was familiar with the action client and things like that. So, writing the action client server or action client wasn't too difficult, and as far as calling the the inherent server was not too difficult. Um, what was difficult was figuring out how
The label, no?
yes, how to figure out how to get the data that I wanted out of the spots file. So I had this spots info, and that I was just calling, from my file, and I was getting errors, and so what I ended up doing was doing loggers and just seeing what exactly spot info was equaling, and initially it was info just equals the spots file, so I was getting all of my coordinates, all of their names and their coordinates. Is that okay? And I can break it down. And this is where I learned how to break down from the file inside of a dictionary. You can go dictionary, 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 and was able to dig into each dictionary to get what I needed based on the label name.
Mm-hmm.
Um, so for example, let's move to spot. Here we go.
So right now you are saving a spot.
Right,
Uh-huh.
saving a spot. And so now we should have, yeah, a real robot present.
That's cool that it adds it on top. That's nice. That,
So I also figured out that took me some time too because I really wanted X to be saved first, because I thought it mattered in how I called the data. And dictionaries will, what I learned, always do this stuff alphabetically.
mm.
So didn't matter when I added R present, it was always going to be at the bottom of this list. So if we back up just a little bit, move to another spot. I mean, it's not going to be amazing, but
No, but it's a new point that we can
new
send it
new
to.
point, and
Yeah.
we can
That's basically the project. Yeah.
in there. I mean, it's within this certain,
The tolerance.
yeah.
So
So
if
that
you're
was the
gonna,
other thing I had to
mm-hmm.
do down here on this RViz, when you start off with the basic default tolerances given in the program, this whole map is blacked out.
Right.
So you have to go through and adjust the inflation layers on the object. Well, that was another thing I didn't do initially. I just had the map and where it thinks the objects are and adjust the inflation layers until it all works out. And then I would run it around, and every now and then I would hit one of the movable obstacles from somebody's previous project or whatever. It had been moved out of place. And so I had to go back in and add obstacle layer, add the local cost map and all that stuff. So what you see showing up now in these colors,
Mm-hmm.
so that I could actually avoid those during the moves.
Right, the ones
So
that aren't present in the map you created, basically.
right,
Mm-hmm.
right. So yeah, that was my project. Oh no, yeah, that's the last part, the very last part, which was also a very frustrating part. This is in the project, this is how they tell you to call the submit your to the inherent action server. Um,
You have to hit the
so
full
this
path.
this would have been this is where my action client uh, code is, and this is the project. Here's the code's name, and this is the part that I ran into trouble with was that uh, Ross didn't know where my spots file was. So I thought, well, maybe I'll just add it to the config file with all of the other YAML files and tried that. That didn't work. I made sure that was in my setup folder to make sure that the config file was also shared. It was posted online on the forums about it. Got some help, and they were basically telling me the same thing. Make sure it's in your setup file. Delete all the install files, delete the log styles, defeat the build files, folders. Um, Start again fresh and try it, and still no luck. So what I figured out was that it doesn't know or didn't know where my spots file is located. So I had to manually feed it its project or the path, and after I feed it the path, um, everything was fine.
Right.
And so in all of my other calls, anytime I'm referencing that spots file, I just kind of default to this spelled out path.
Right. So if you would have to run the top one on the actual place that the file was, it would find it. But yeah, I understand. So that's why people use afterwards. This is not part of the project, but that's one of the
Mhm.
benefits of the launch files. You can do the find package share, and then it just automatically finds whatever you're looking for. Uh, yeah.
So say that again?
So you can put, you know how you're doing ROS to run. So you're
Y-
running the executable in there,
Yeah.
and then you have to put the full path of the spots file. So if you were to create a launch file for this executable, so you know the something like
Yes,
this, and you see
I
how they're
understand.
doing this here, get package shared directory. That's basically
Yes.
what you're looking for. So it's an extra, yeah, it's an extra thing that kind of finds your the equivalent would be like the Python path, and then just puts it there. So
And then use the parameters for the whichever spot I wanted
yeah,
in.
exactly. It's actually more difficult to do Rust to run and then figure that out. So thank you for letting me know that. I'm gonna add in the instructions, the path, so people don't get stuck in there because yeah. Thank you.
Yeah, let me I'll show you. This is okay. So yeah, it's doesn't know. This is what the default command
Uh huh.
is telling you.
Right.
And um but yeah, that's those are the hurdles that I had to overcome is learning how to decipher some of the error codes and then um adjusting the inflation boundaries so that I could actually move around give the robot some space to run.
Mm-hmm.
Adjusting the robot radius also helped. And I also adjusted the speed and acceleration because I noticed that sometimes when I was doing like a long path, like if I was in the bottom of a corner and going to the complete opposite corner, um, if I would turn it and start moving really fast, I'd sometimes uh, get really close to the other obstacles, and it would do that recovery behavior and start spinning
Mm-hmm.
or back up or whatever. And so I just told it I gave it smaller acceleration, smaller linear speed, and it would that way it could orient itself faster before moving forward.
Yeah, I noticed that. It was moving nicely, smoothly. When you
Yeah.
set it up right away, it can do jerky, and then it also depends on the controller frequency that you're giving it. So if it's going way too fast and your controller frequency is way too slow, you might have like problems there too. But okay, nice.
Yeah. And so that's my project.
That's your project. All right. Cool. Justin, congratulations. Really, really nice project. Really straight into the point. So I want to congratulate you. And I want to actually address some of the challenges you mentioned at the beginning. So I forgot. Could you go up in your slides? So yes, this one exactly, the AMCO versus odometry issue, which is confusing, and for so the reason why odometry wouldn't work was basically because, well, two things. Basically, I think when you start the simulation, the autumn topic is always going to be 000, right? Because that's a plugin from Gazebo, and you just start it up unless you change it for whatever reason. That's 000. And then the real robot, we do restart the controllers, but we don't actually know. So the odometry can be whatever, it can be a random number because it's been running for a while. So, it moves around. So that number is completely different. So that's why your odometry calculations was having that. And the solution is moving to the AMCL pose. Yes, because actually AMCL pose, what it does, so it basically publishes map to autumn, the frames map to autumn, because when you start your robot or your simulation, you should always have your odometry frame, which is different than the odometry topic, right? The odometry topic is just the messages of the encoder of the motor, telling you, the clicks that it has done, and it just spits it out on there, right there. And the AMC, in the other side, the odometry frame, kind of, you define that when you launch your controllers with the robot state publisher, it's called, which is basically where you defined the relationships between the wheel of the robot and the scanner, so you can do all these navigations and the TF tree. So what AMCL does is it does that connection between map and autumn, and funnily enough, that map frame is done wherever you start mapping. So if you start mapping, in a corner, that's going to be your 000 of the goals you send will be with respect to that value. So it actually matters a lot where you start mapping. You can adapt it later. You can go in the YALM file and change the origin and parameters of your file. But then that connection gets published, from map to autumn, and then you can subscribe to the AMCL post because it's actually when you move it, it is when it appears. So it's always with respect to that place where you started mapping. So if you start mapping in a different place than the simulation, you're also going to have differences in that AMCL post.
So the only one that would work is whenever I was doing the ODOM
Mm-hmm.
is the 000. That one always returned me to pedestrian. And was always confused as to why that worked
Because you started
in
mapping there, probably.
yeah, so whenever you start the simulation and you're doing the initial mapping, creating the map and all that stuff, your simulation starts at the
Right
pedestrian
there,
spot.
yes. Yes, yes.
So 000 on AMCL pose and 000 on ODOM that's the only one that's the same.
Mm-hmm.
And that
And
makes sense now.
that's the reason. Yes, yes, yes. So it is a very good point because yes, my first thought also is just look at the odometry. But basically, you're using the AMCL pose, or people also use the initial position, the initial pose. The one you click, they subscribe to that, and it's like I want to go here, but it's gonna be always with respect to that origin where you start mapping. And again, you can move it wherever you want. Let's say, for example, when I set up nav, I like to put it in a place where everything's going to be positive, right? So 1 meter, 2 meters up, and that way I can kind of see it in my head. You can actually move it, the X and Y, but you can't rotate it because then the local and global cost maps won't adapt to that. So you'll have problems because nav2 just didn't consider that. You have to go in there and do the work yourself. But yeah, I thought that was very interesting, and so I wanted to maybe clarify that and why you should always do AMCL pose when you start up navigation, because you can't depend, especially on these kinds of robots, maybe in really nice ones, but you're always going to have drift in the wheels, and like this, it's always running, so you can't depend on that odometry. But yeah, I wanted to mention that because I thought that was really, really interesting. And I understand you're paying from simulation to real robot there. And
Yeah, I appreciate the help on that.
but I mean, other than that, you again, I really liked it. It looked, I mean, really fine tuned, really nicely, and it looks like you spent your time in there, which is what you need to do when you turn to the real robot, because you're gonna find new things to tune out and to figure out there. But other than that, Justin, I just want to say congratulations. A really, really nice, really straight to the point project.
Thanks.
All right, awesome. Well, great. So then that's it for us, guys. So let me just change here over here. So yeah, this is what you can do when you are doing our courses and you complete our courses and you're interested in getting a certificate from us. You can do what Justin did here and present your project on a real environment. So I invite everyone to keep pushing your ROS learning. And Justin, thank you very much one more time, and we hope to see you again soon.
Thanks.
All right. Bye-bye, guys. See you next time. All right, cool. We are done.